Chapter 10. The Yellowstone National Park. While the preceding chapters of this report were passing through the press, the bill that was introduced into both houses of Congress in December has become a law. It will perhaps be proper, therefore, to devote a small space to a notice of this event, omitting the details until the more complete history can be prepared. In order that the geographical locality of the reservation, containing within its boundaries the wonderful falls, the hot springs, the geysers, and so on, described in the previous chapters of this report, may be more clearly understood, I have prepared a map expressly to show the park with its surroundings on a scale of 10 miles to 1 inch. The report of the Committee on Public Lands, as well as the law itself, which is included in this chapter, will serve to explain the map in general terms. A glance at the map will show to the reader the geographical locality of the most beautiful lake in the world, set like a gem among the mountains. He will also see that the mountains that wall it in on every side form one of the most remarkable watersheds on the continent. The snows that fall on the summits give origin to 3 of the largest rivers in North America. On the north side are the sources of the Yellowstone. On the west, those of the 3 forks of the Missouri. On the southwest and south, those of the Snake River, flowing into the Columbia and thence into the Pacific Ocean, and those of Green River, rushing southward to join the Great Colorado, and finally emptying into the Gulf of California, while on the east are the numerous sources of Wind River. From any point of view which we may select to survey this remarkable region, it surpasses, in many respects, any other portion of our continent. On the 18th of December, 1871, a bill was introduced into the Senate of the United States by Honorable S.C. Pomeroy to set apart a certain tract of land lying near the headwaters of the Yellowstone River as a public park. About the same time, a similar bill was offered in the House of Representatives by Honorable William H. Clagett, delegate from Montana. After due consideration in the Committees on Public Lands in both houses, the bill was reported favorably. In the Senate, it was ably advocated by Messrs. Pomeroy, Edmonds, Trumbull, Anthony, and others. In the House, the remarks of Honorable H. L. Dawes were so clear and forcible that the bill passed at once without opposition. I have thus presented a brief history of the passage of this bill because I believe it will mark an era in the popular advancement of scientific thought, not only in this country, but throughout the civilized world. That our legislators, at a time when public opinion is so strong against appropriating the public domain for any purpose, however laudable, should reserve, for the benefit and instruction of the people, a tract of 3,578 square miles, is an act that should cause universal joy throughout the land. This noble deed may be regarded as a tribute from our legislators to science, and the gratitude of the nation and of men of science in all parts of the world is due them for this munificent donation. The Yellowstone Park. Mr. Dunnell, from the Committee on the Public Lands, made the following report. The Committee on the Public Lands, having had under consideration Bill H.R. 764, would report as follows. The bill now before Congress has for its object the withdrawal from settlement, occupancy, or sale, under the laws of the United States, a tract of land 55 by 65 miles about the sources of the Yellowstone and Missouri rivers, and dedicates and sets it apart as a great national park or pleasure ground for the benefit and enjoyment of the people. The entire area comprised within the limits of the reservation contemplated in this bill is not susceptible of cultivation with any degree of certainty, and the winters would be too severe for stock raising. Whenever the altitude of the mountain districts exceeds 6,000 feet above tidewater, their settlement becomes problematical unless there are valuable mines to attract people. The entire area within the limits of the proposed reservation is over 6,000 feet in altitude, and the Yellowstone Lake, which occupies an area 15 by 22 miles, or 330 square miles, is 7,427 feet. The ranges of mountains that hem the valleys in on every side rise to the height of 10,000 and 12,000 feet and are covered with snow all the year. These mountains are all of volcanic origin, and it is not probable that any mines or minerals of value will ever be found there. During the months of June, July, and August, the climate is pure and most invigorating, with scarcely any rain or storms of any kind. But the thermometer frequently sinks as low as 26 degrees. There is frost every month of the year. This whole region was, in comparatively modern geological times, the scene of the most wonderful volcanic activity of any portion of our country. The hot springs and the geysers represent the last stages, the vents or escape pipes of these remarkable volcanic manifestations of the internal forces. All these springs are adorned with decorations more beautiful than human art ever conceived, and which have required thousands of years for the cunning hand of nature to form. Persons are now waiting for the spring to open, to enter in, and take possession of these remarkable curiosities, to make merchandise of these beautiful specimens, to fence in these rare wonders so as to charge visitors a fee, as is now done at Niagara Falls, for the sight of that which ought to be as free as the air or water. In a few years, this region will be a place of resort for all classes of people from all portions of the world. The geysers of Iceland, which have been objects of interest for the scientific men and travelers of the entire world, sink into insignificance in comparison with the hot springs of the Yellowstone and Firehole basins. As a place of resort for invalids, it will not be excelled by any portion of the world. If this bill fails to become a law this session, the Vandals, who are now waiting to enter into this wonderland, will, in a single season, despoil beyond recovery these remarkable curiosities, which have required all the canning skill of nature thousands of years to prepare. We have already shown that no portion of this tract can ever be made available for agricultural or mining purposes. Even if the altitude and the climate would permit the country to be made available, not over 50 square miles of the entire area could ever be settled. The valleys are all narrow, hemmed in by high volcanic mountains like gigantic walls. The withdrawal of this tract, therefore, from sale or settlement, takes nothing from the value of the public domain, and is no pecuniary loss to the government, but will be regarded by the entire civilized world as a step of progress and an honor to Congress and the nation. Department of the Interior, Washington, D.C., January 29, 1872. Sir, I have the honor to acknowledge the receipt of your communication of the 27th instant relative to the bill now pending in the House of Representatives dedicating that tract of country known as the Yellowstone Valley as a national park. I hand you herewith the report of Dr. F. V. Hayden, United States geologist, relative to said proposed reservation, and have only to add that I fully concur in his recommendations, and trust that the bill referred to may speedily become a law. Very respectfully, your obedient servant, Honorable Aim H. Dunnell, House of Representatives. C. Delano, Secretary. The committee, therefore, recommend the passage of the bill without amendment. General Nature, Number 16. An act to set apart a certain tract of land lying near the headwaters of the Yellowstone River as a public park. Be it enacted by the Senate and House of Representatives of the United States of America in Congress assembled, that the tract of land in the territories of Montana and Wyoming lying near the headwaters of the Yellowstone River and described as follows, to wit, commencing at the junction of Gardner's River with the Yellowstone River and running east to the meridian passing 10 miles to the eastward of the most eastern point of Yellowstone Lake, thence south along said meridian to the parallel of latitude passing 10 miles south of the most southern point of Yellowstone Lake, thence west along said parallel to the meridian passing 15 miles west of the most western point of Madison Lake. Thence north along said meridian to the latitude of the junction of the Yellowstone and Gardner's rivers. Thence east to the place of beginning is hereby reserved and withdrawn from settlement, occupancy, or sale under the laws of the United States, and dedicated and set apart as a public park or pleasuring ground for the benefit and enjoyment of the people, and all persons who shall locate or settle upon or occupy the same, or any part thereof, except as hereinafter provided, shall be considered trespassers and removed therefrom. Section 2. That said public park shall be under the exclusive control of the Secretary of the Interior, whose duty it shall be, as soon as practicable, to make and publish such rules and regulations as he may deem necessary or proper for the care and management of the same. Such regulations shall provide for the preservation, from injury or spoliation, of all timber, mineral deposits, natural curiosities, or wonders within said park, and their retention in their natural condition. The Secretary may, in his discretion, grant leases for building purposes for terms not exceeding 10 years of small parcels of ground at such places in said park as shall require the erection of buildings for the accommodation of visitors, and all of the proceeds of said leases and all other revenues that may be derived from any source connected with said park to be expended under his direction in the management of the same, and then the construction of roads and bridle paths therein. He shall provide against the wanton destruction of the fish and game found within said park, and against their capture or destruction for the purposes of merchandise or profit. He shall also cause all persons trespassing upon the same after the passage of this act to be removed therefrom, and generally shall be authorized to take all such measures as shall be necessary or proper to fully carry out the objects and purposes of this act. Approved March 1st, 1872. Chapter 11. Report of A.C. Peale, M.D., on minerals, rocks, thermal springs, and C. Washington, D.C. Dear Sir, I have the honor to transmit herewith my preliminary report on the minerals, rocks, and thermal springs met with during the explorations of this summer. I commence at Ogden, Utah Territory, our starting point, and describe the minerals, rocks, and springs encountered by the expedition throughout the whole trip. To study the mineral resources of a country to the best advantage requires that we should have an abundance of time to devote to each locality, working on our knees, as it were, with drill and hammer. As the greater part of our time was spent on the march, such a course was impracticable. I therefore confined myself to the collection and general investigation of specimens. 627 specimens of rocks, with over 1,000 specimens of minerals, including those from the hot springs, have been deposited in the Smithsonian Institution. Catalogs of the minerals and rocks are appended to this report. I insert qualitative analyses of the waters of the principal geysers and hot springs. In so doing, I feel a hesitancy, for the field is so vast that to develop it thoroughly would require the work of years, and the number I present is but as a drop of water in the ocean. I had hoped to embody in this report a larger number of quantitative analyses, but the time has been limited, and there have been interruptions that have rendered it impossible. I append a catalog of the hot springs of which the temperatures were recorded, giving their position, elevation, character, principal constituents, highest, lowest, and average temperatures, together with the temperature of the air at the time of observation. In regard to mining operations, I have not attempted to make any report. We passed through but a small portion of the mining districts, so that any such report would be incomplete. In conclusion, I wish to express my thanks to the members of the expedition for their assistance and cooperation, and also to Judge Lovell of Virginia City, Montana Territory, and C.T. Duell, Esquire, of Evanston, Utah, for information afforded me. I would also refer to the uniform kindness and courtesy extended to us at the various military posts. Hoping this report may meet all requirements, I am, very respectfully, your obedient servant, Dr. F. V. Hayden, A.C. Peale, United States geologist. Ogden City in Utah Territory is situated at the western base of the Wasatch Mountains in the Salt Lake Basin. It is between the Ogden and Weber rivers and is the point where the Union Pacific, the Central Pacific, and the Utah Central Railroads effect a junction. The town contains about 6,000 inhabitants and is built partly on the terrace that skirts the base of the mountains and partly on the level bottom through which the rivers flow. Its streets are all wide and lined with beautiful trees, while on each side flows a clear stream of fresh spring water. The Wasatch Range extends north and south, its gray peaks being snow-crowned the greater part of the year. Our first camp after leaving Cheyenne, Wyoming Territory, was on one of the terraces, about a mile from the foot of the mountains, which are cut into sections by numerous canyons. They intersect the range at right angles to the trend. One of them, Ogden Canyon, I visited as typical of the others. The rocks at the mouth of the canyon I found to be syenites of a red color and having a specific gravity of 2.6. The feldspar in it was a flesh-colored orthoclase alone. The only veins noticeable were some illy defined of quartz and feldspar. These syenites must in places pass into granites, for a specimen brought me I found to be a protogene containing a green talc, which, with the flesh-colored feldspar and white quartz, formed a beautiful specimen. The rock, however, could not be located. In this syenite, at the distance of probably half a mile to the south of Ogden Canyon, some prospectors have claimed to have discovered tin ore. The specimens brought me, I failed to discover even a trace of tin. Upon the syenites, very thick beds of quartzites lie. They are mostly of a white color. In some places, however, they are dark brown and highly ferruginous. The specific gravity of these quartzites varies from 2.5 to 2.6. They extend for some distance and dip at an angle of about 80 degrees. I found also a metamorphic conglomerate, composed of beautiful red and pink siliceous pebbles embedded in a light gray siliceous matrix. The quartzites are succeeded by quartz schists, which in turn pass into a dark curty or siliceous limestone. This limestone produces an excellent quality of lime, which has been used by the Union Pacific Railroad Company in building their engine houses. There are in the canyon 3 lime kilns in active operation. Farther up the canyon than I was able to go, I was told there was a ledge of silver ore that promises to pay well. A piece of ore that was handed me, and alleged to be from the same, yielded, on examination, both silver and copper. I was also given a piece of coal, said to be from some distance up the canyon. We left Ogden on the morning of June 10th and took up our line of march, traveling in a northwesterly direction along the base of the mountains, around Bear River Bay, and in the afternoon camped in a beautiful small green valley, having gone 10 miles. Near our camp were situated some hot springs, very noticeable from the abundant, deep, crimson-colored deposit about them. There are a number of springs at the base of a spur of the mountain range, which is to the east of them. The average temperature of the water was 129 degrees Fahrenheit, and the temperature of the air at the time of observation being 83 degrees Fahrenheit. The highest temperature was found in one of the smaller southern springs and was 136 degrees Fahrenheit, while at the distance of 100 feet to the west of it, the lowest temperature, 109 degrees Fahrenheit, was found. The principal spring was almost circular in shape, and from 12 to 15 feet in diameter and 5 feet in depth. Its temperature was 128 degrees Fahrenheit. Some distance from its edge, although probably higher in the center, beyond the reach of the thermometer. The taste of the water was decidedly bitter and salty. In all of the springs, there was at intervals a slight bubbling of carbonic acid gas. At no time during observation, however, was it considerable. No other volatile substances were discovered. The specific gravity of the water was 1019, and an analysis revealed the following constituents. Chloride of sodium, common salt, very abundant. Sulfate of lime, magnesia, lime, iron as carbonates. The amount of iron was small, from its having been thrown down by the escape of the carbonic acid gas at the time of examination. A considerable area around the springs is covered with a deposit of iron, the bright red color of which contrasts well with the green of the surrounding vegetation. In isolated spots, as well as on some of the rocks near the water, there is a white deposit. Between the springs and the lake or bay, there extend salt marshes or flats for the distance of 3 or 4 miles. Leaving our camp on the 12th, we resumed our way in an almost northerly direction until we neared Brigham City, when we turned to the right and entered Box Elder Canyon, another of those gorges cut through the mountains at right angles to its trend. Our way was now upward for 8 miles through the canyon grass-covered hills, with here and there projecting rocks rising high on either side of us, while at our feet rushed a swift stream, its banks fringed with elder bushes. The rocks here are identical with those in Ogden Canyon. In the evening, we camped in Box Elder Park, about 500 feet above the level of the Salt Lake, near the Danish settlement of Copenhagen. The park is almost circular in shape and is about 2 miles in diameter, encircled by rounded hills composed of dark, silicious limestone. Between this point and Cache Valley, a distance of almost 13 miles, our road led us now uphill and now down, past masses of dark blue carboniferous or mountain limestones, containing white calcite with perfect cleavage. They are fossiliferous. Just before reaching Wellsville, our camping place, there was a change to calcareous sandstones of a light gray color. The scene as we emerged from the mountains was grand. Before us lay Cache Valley, dotted with numerous Mormon towns. It is one of the best cultivated districts in Utah, and clothed in its spring garb, presented a beautiful appearance. It is about 54 miles in length and will average about 7 miles in width. The rocks in the mountains on either side are limestones and quartzites. Near Mendon, there occurs an oolitic limestone, which is much used for building purposes throughout the valley. Our course on the 14th and 15th lay through Cache Valley. At the upper end is the town of Franklin. To the west of the town there is a large, isolated butte, the basis of which is a blue limestone containing a percentage of silica. This stands in the middle of the valley like some monument, the surrounding rock having been washed away. On June 16th, we crossed Bear River and found immediately a change in the rocks. Instead of limestone, we came across greenstone, among which I obtained specimens of aphenite and mellifier, the latter amygdaloidal in places. The specific gravity of some of these specimens is as follows: 3 specimens of dark green aphenite, 2.5, and 2 specimens of mellifier, 3.1. Continuing for about 5 miles, they are intercepted by quartzites containing a small percentage of lime. About 3 miles above the town of Oxford, I found some men mining for silver. W.J. Cooper of Oxford is the owner of the lode, which is 7 feet wide and dips west at an angle of about 40 degrees. The strike is north and south. The wall rock on either side is greenstone. The gang of the lode is composed of quartz with calcite and feldspar. Some good crystals of calcite were seen, and also brown spar, rhomb spar. The ore is principally chloride, reddish and greenish. A shaft has been commenced, but has reached only the depth of 30 feet. 6 miles above Oxford, we entered Marsh Creek, or Round Valley, passing from Utah into Idaho territory. The entrance to this valley is between 2 high buttes, one consisting of a ferruginous sandstone of a bright red color on its weathered surfaces, the other composed of a bluish, silicious limestone. Passing through this natural gateway, we were in an old lake basin, the rocks being modern Pliocene sandstones of a white color, all containing some lime. The road soon ascended to the top of a terrace of drift formation, covered with a sparse growth of sagebrush. Leaving this valley the following day, June 18th, we entered the valley of the Port-Neuf River. Just before entering the valley, we passed over a floor-like layer of dark basaltic rock. We followed the river on its right bank. All along the left bank, there is a layer of basaltic rock, its hexagonal columnar form reminding one of the Giant's Causeway. The formation over which our road led us was drift, while the hills on our right presented alternations of limestones and quartzites succeeding each other at short intervals. There seems to have been some point higher up the valley from which the molten mass flowed during the Tertiary period, for the formation on which it rests is Tertiary. In crevices in the rock in many places, I obtained specimens of obsidian. As we neared the mouth of the valley, it became wider and wider, and the mountains receded until they spread out into the Suake River Valley. Emerging into the valley, we turned to the right and crossed the hills to Fort Hall, a post that has only recently been established in Idaho Territory. We arrived there on the 21st of June. The following day, I made a visit to some warm springs in Lincoln Valley, about 3 miles southeast of the fort. I found 5 springs situated at the head of a depression in the valley, whose direction was east and west. They gush forth from the foot of the hills, the bases of which are limestones. In spring number 1, which was the warmest, the thermometer recorded 87 degrees Fahrenheit. It was about a foot in diameter, nearly circular, and 9 inches in depth. The next two, number 2 and number 3, to the southeast of number 1, had equal temperatures, each being 77 degrees Fahrenheit. Only one of these was defined as a spring, being 3 feet in diameter and 2 feet in depth. In the other, the water merely poured forth from the rocks in a narrow stream. Number 4 and number 5 were of the same character as the last mentioned, and reached each the temperature of 69 degrees Fahrenheit. They were still more to the east. The water in all was beautifully clear, due to the presence of carbonate of lime. The specific gravity of the water was 1003 and contained carbonate of lime and alumina, probably as a sulfate. There was no perceptible evolution of gas. In the course of the stream there was a deposit of lime, small in quantity, encrusting grass, moss, and twigs. About a mile east of the fort I found a number of hills, whose bases are fine-grained red sandstones of very free quality. It would make a very good ornamental building, stone. The rocks that succeed and lie upon them are Jurassic limestones, containing an abundance of fossils. We left Fort Hall on the 23rd of June, and until the 28th were in the Snake River Valley, a wide plain covered with sand and sagebrush. For 90 miles, nothing else was passed over, save here and there exposures of dark basaltic rock, which seems to be spread out over the entire plain. At some time, during or since the Tertiary period, the plain must have been flooded with molten lava, which came in all likelihood from several points of eruption. As we came down the Port-Neuf River, we could see in the distance what appeared to be an old crater, and on our way across the Snake River Basin we passed another. At Eagle Rock, we crossed Snake River on Taylor's Bridge. The river here has cut a narrow gorge through the rock, forming quite a canyon. The rock rises 10 feet above the level of the water. The current is very swift. The rock shows the hexagonal columns, so characteristic of the cooling of the molten mass. At Hole in the Rock, on Dry Creek, we had an opportunity of proving that the lava extends over the valley like a crust, for the most part at least simply, and not in the form of dikes. Here we visited a cave which has been formed by the water flowing beneath the basalt and washing out the sand. The entrance to the cave is formed by a falling in of the crust. Clambering down over the broken fragments, we discovered 7 chambers. There were 2 entrances, one to the northwest and the other to the southeast. In the first, named direction, we found 3 chambers, each about 25 feet in height and 200 feet in diameter, they being almost circular. The chambers are separated from each other by loose fallen rock. After penetrating as far as possible, we retraced our steps and were about leaving the place when we discovered an aperture just large enough to admit one at a time leading toward the southeast. Entering this, we found 4 chambers, separated from each other by piles of loose, fallen rock, as in those on the opposite side. Instead of being circular, these were oblong in shape, each being about 300 feet in length and 150 feet wide, the height being 20 feet. Each succeeding chamber is somewhat lower than the preceding. The roof is arched and composed of dark basaltic rock. From it there hang innumerable small stalactitic formations, caused by the percolation of the water through the rock. There are also numbers of air bubbles in the rock, which hang from the roof in drop-like processes, forming points for the formation of stalactites. The bottom of the cave is sandy, and in a hole dug to the depth of 20 feet, it was observed to be distinctly stratified, showing it to have been deposited by water. That this condition extends over the whole valley is further presumable from the fact that a considerable number of the streams flowing through it sink and are lost to sight. Their disappearance is easily accounted for by their flowing underneath this crust. On the 28th of June, we left the Snake River Basin and, entering Beaver Head Canyon, began to ascend on our way across the main divide of the Rocky Mountains. The igneous rocks were still present. At the mouth of the canyon, we passed an isolated hill composed of schistose or slaty phonolite, each layer being 1/8 of an inch in thickness and porphyritic. Its specific gravity is 2.39. On reaching the top of the canyon, we encamped in Pleasant Valley, a beautiful little valley set in the mountains like a gem. Its elevation is 6,086 feet. Near our camp was a deep, narrow gorge cut through rock, which on examination proved to be a true porphyritic phonolite, having disseminated through it crystals of sanidine, nepheline, and hoyonite. The rock is of a dark gray color, very compact, having a specific gravity of 2.75. The crystals occurring in spots occupying about 1/4 of an inch each and from 1 to 2 inches apart. The hoyonite occurs as reddish, octagonal crystals. The nepheline is the variety somite and is in small grains, while the sanidine, or orthoclase, is in tabular crystals. I insert here the mineralogical composition of some phonolites of Bohemia, given by G. Jentsch. Sanidine, estimated at, nepheline, estimated at, hornblende, arvensonite, titanite, pyrites. Percent, 53.55, 31.76, 9.34, 3.670.04. I shall take the earliest opportunity of making a chemical analysis of this rock. The occurrence of these phonolites would go far toward proving the age of the eruption, even though we had not the tertiary formations beneath it, for no true phonolite has been found to be of other than tertiary or still more recent origin. The following day we continued on our way across the mountains, passing over the divide, the elevation of which was 7,044 feet. The more modern rocks were conglomerates, presenting little or no interest. I obtained some specifics of trachyte, which are vesicular, of a white color, having a reddish tinge in some parts. I also obtained specimens of a vesicular rock, which I considered to be a phonolite, although I had not the opportunity of observing it in position. One of the specimens was of a dark gray color, having a specific gravity of 2.57. The specific gravity of the light varieties was 2.3. After crossing the divide, our way lay over Pliocene formations, in which I obtained a white sandstone composed of very fine pebbles, cemented by a calcareous matrix. The older rocks were limestone conglomerates, upon which rested white and red sandstones. The 30th of June we spent in camp, visiting a peak near us, where we found the limestone conglomerates at the base with sandstones on top. The next day our route was through a rolling country, now passing over a hill, and now through the valley of a small stream. I procured specimens of a very compact, dark phonolite, having a specific gravity of 2.4. The recent rocks were of Pliocene origin. Some of them consist of very small, bluish, siliceous pebbles in a white siliceous matrix. Upon these were grayish calcareous sandstones, also Pliocene. They consist of minute red and black pebbles cemented by lime. On top of these were yellowish calcareous marls. We camped at night at an elevation of 6,988 feet, in the midst of gneissic hills, which become granitoid in places. The following morning we entered Wildcat Canyon, a picturesque, gorge-like valley, the rocks of which stand out boldly on either side. At the head of the canyon, I found a vein of coarse granite, containing labradorite in good cleavable masses. In some of the specimens, the play of colors was particularly fine. There were also some good crystals of black mica, biotite. The surrounding rocks were fine-grained granites of a reddish hue. On top of the granites were quartz porphyries, or elvenite, which passed into felstone, or petrosilex. In some places there appeared to be a dike running through the granite. The elvenite I found of two varieties, one having a gray-colored matrix with feldspar crystals of a pink tinge, and the other having a red matrix with white crystals disseminated through it. The petrosilex, or felstone, was of various shades, blue, gray, yellow, and red predominating. The yellow variety has a specific gravity of 2.01, the blue 2.53, and the gray 2.72. These rocks seem to pass into gneiss, which itself at some distance becomes granitoid, thus proving them to be of the same composition as granite, only in a more compact state, having been forced through the granite and therefore of later origin. We camped in the evening of the 2nd of July on Black-tailed Deer Creek. Leaving here the following morning, the first part of our course led us up over hills that were once the bottom of some large lake. Reaching the top, a grand view burst on our sight. We stood on the rim of a vast amphitheater. At its bottom, far beneath us, was a green line marking the course of a stream, one of the branches of the Stinking Water River. The rounded hills converged toward the stream, while here and there, on their sides, were projecting strata of white Pliocene sandstones, contrasting well with the grassy slopes. On the top, even underneath our feet, was a capping of black basaltic rock, which on some sides projected over the edge. So regular was it that it seemed as though it had been laid with mathematical accuracy. The background completing this picture was composed of sharp peaks and hills, with a blue snowy range in the extreme distance. We now began to descend, proceeding down the canyon, which is named the Devil's Pathway. Our road led us between masses of gneissic and granitoid rocks. Here again we found dikes of elvenite, quartz porphyries, and felstones, some of beautiful colors, red, blue, gray, and violet. I obtained a striped or slaty porphyry looking very much like ribboned jasper. Emerging from the rocky walls, we pitched our tents on the bank of the Pasamaria, or Stinking Water River. The next day we again passed over modern formations in an old lake basin until within some 10 miles of Virginia City, when we came across quartzose rocks, mostly auriferous. Here we found the first evidences of mining. Near the road, a man by the name David Lloyd was industriously washing out the gravel from the side of a foothill. He informed me that he was averaging about $3 per day. Passing between Quartzose and Gneissic hills, containing veins of garnetiferous hornblende schist, we soon began to ascend, and crossing the hills, passed through Nevada, a small mining town below Virginia City. All about us were the evidences of mining in the heaps of bare pebbles, numerous watercourses, and upturned barrows. It being the anniversary of our national independence, all were idle save a few Chinamen. Virginia City is situated in Madison County in the southern part of Montana and is one of the chief mining centers of the territory. It is on Alder Gulch, one of the tributaries of the Stinking Water or Pasamaria River. The mines about Virginia City are principally placer diggings. Gold was discovered on Alder Gulch in 1863, being the second discovery in the territory, the placer diggings of Bannock having been discovered in 1862. Since that time, enormous quantities of gold have been taken out, although it is impossible to say exactly how much, as the estimates are conflicting. Alder Gulch is about 16 miles long and has a number of tributaries, all of which contain gold. Bald Mountain stands at the head of the gulch. Near it, the gold is coarse, and the farther we go from it down the gulch, the finer it becomes. The width of the gulch will average about 200 feet, and the hills on either side are rounded. The country rock is gneiss, presenting the same characteristics as that I have before noticed, being in many places garnetiferous. The gravel is washed through a flume, and the gold caught at various parts of its length. One of the greatest wants for the successful prosecution of mining here is a water supply. There are a number of quartz mines about Virginia City, but all unite in saying that more capital is needed to make them pay well. I was shown specimens of argentiferous galena and of copper ore, which will no doubt one day add much to the prosperity of Montana. The copper, I was told, was being mined and sent to California to be smelted. In Alder Gulch, I obtained good specimens of garnets and precious serpentine. We left Virginia City on the 6th of July and crossed the hills to the Madison River, traveling in a northerly direction. We passed over dark igneous rocks which were in contact with coarse ferruginous sandstones. We followed the river until its passage through a narrow canyon necessitated our turning from it and crossing the mountains. Soon after leaving the river, we crossed Meadow Creek, which flows through an exceedingly beautiful and fertile valley. We now began to ascend rapidly and passed by 3 deserted shafts sunk in the granite beds. Besides granites, there are here quartzites and gneiss. Soon after crossing the summit, we encamped in the Hot Spring district. Near our camp were some hot springs, which, however, presented but little of interest. The highest temperature was 76 degrees Fahrenheit and the lowest 64 degrees Fahrenheit, the temperature of the air being 48 degrees Fahrenheit. The largest spring was only about 1.5 feet in diameter and 4 inches in depth. The rock at whose base they have their origin is a reddish syenite. A few miles farther on, we passed some larger springs situated close to the road. Their size was about 4 feet by 10 feet. The highest temperature here was 124 degrees Fahrenheit and the lowest 110 degrees Fahrenheit, the atmosphere at the time of observation being 50 degrees Fahrenheit. They were filled with confervoidia. We passed by a number of mills, all working, being supplied with the gold ore from quartz mines in the neighborhood. One of these mines, the Red Bluff lode, I visited. The lode, which is owned by J.J. Lown, dips to the north, the strike being east and west. Its width varies from 2 feet to 7 feet. The country rock is mainly gneiss. The hanging wall is a gray granite, and its footwall gneiss. There are 2 shafts 100 feet apart, the first one reaching the depth of 105 feet and the second 110 feet. They are connected by a passage which extends 45 feet beyond the second shaft, getting below the water level. The ore is principally a red jasper with the particles of metallic gold disseminated through it and plainly visible. Below this jaspery ore, there are galena and pyrites. I also obtained some beautiful pieces of blue chalcedony and some semiopal, the latter being almost all dendritic. Approaching the hanging wall, the ore passed into a porphyritic rock with large masses of bright red jasper. The mine had been worked for 6 months, and in that time had averaged $60 to the ton. There were about 8 men employed at the rate of $3 each per day. Leaving here, a ride of a few miles brought us a second time to the Madison River, which, having cut its way through the mountains, here spreads out and flows smoothly between low, rounded hills, from whose grassy slopes ridges of gneiss and hornblende schist project. On examination, these latter proved to be garnetiferous. Following the Madison but a short distance, we turned to the right and crossed the hills to the valley of the Gallatin River. This is the Garden Valley of Montana. It will average 15 miles in width and is about 60 miles long. It is well watered by the branches of the Gallatin River, which are extensively used in irrigation. The hills are covered with excellent grass and form one of the best grazing grounds in the world. Quite a considerable part of the valley is already under cultivation. Crossing the Gallatin, we soon arrived at Bozeman City, a flourishing town destined to be of considerable importance should the Northern Pacific Railroad run through it. 3 miles beyond the town, we pitched our tents at Fort Ellis. Fort Ellis is situated on the eastern side of the Gallatin Valley on the east branch of the Gallatin River, and has a force of 4 companies of cavalry and 1 company of infantry under the command of Major E.M. Baker. On the 11th of July, we visited a small lake 12 miles southeast of the fort. After a ride over a trail which led through dense timber, making our progress difficult, we reached the lake, a beautiful sheet of water ensconced in the midst of hills which rise to a considerable height around it. It is about half a mile in width, and the stream flowing from it forces its way in a deep gully through quartzites. It falls about 500 feet in a quarter of a mile. It rushes along with furious rapidity, leaving high projections of rock on either side. The lake shore is bordered with limestones, which rest on the quartzites. Having refitted and obtained an escort, we left Fort Ellis on the 15th, and after a ride of but 9 miles over a very rough road, went into camp. During the day, we passed over fossiliferous sandstones of tertiary origin. At the head of Spring Canyon, through which a small stream flows to join the Gallatin, we passed an old coal mine. It is abandoned, and being full of water, prevented our entrance. The shaft, however, does not penetrate very far. The coal is lignite, similar to that found along the Union Pacific Railroad. On top of the sandstones, we again had igneous rocks, dark basalts. For the 2 following days, we were obliged to travel very slowly, having to build our road in many places. The sandstones and basalts continued until we reached the valley of the Yellowstone River, which we entered on the morning of the 17th. The flow of the lava has spread out over the valley, forming a floor, over which our road led. I obtained on our way chips of chalcedony and obsidian, which were abundantly scattered over the valley. The valley of the Yellowstone, at the point we entered it, is about 4 miles wide, and has on its eastern margin a grand mountain range, whose sharp peaks proclaim its volcanic origin. The river is easily traced by the line of timber on its banks. At Bottler's Ranch, we formed our permanent camp, being unable to take our wagons further, and made preparations to pursue our way with pack mules. On the 20th of July, we left Bottler's, stringing out in single file with our pack train along the trail up the Yellowstone River. The trail led us along the left bank of the river over igneous rock, the most conspicuous of which was a breccia, composed of large masses of black material embedded in a red matrix. After a ride of about 15 miles, we reached the lower canyon. Here the river breaks through masses of gneissic rock, which rise abruptly from the water's edge, and over which our trail was very steep and rocky. The canyon is about 3/4 of a mile in length and about 280 feet wide. At the bottom of this ravine, the river, of an emerald tint, rushes over the rocks, whose resistance causes it to be thrown into numerous foam-capped ripples. The gneissic rocks are for the most part garnetiferous, though somewhat indistinctly so. They pass in many places into hornblende schists, and in others become granitoid. Emerging from the canyon, our way led us alternately over low hills of igneous origin and expanded valleys. The soil seems to be made of the finely pulverized dust of volcanic rock and is covered with a sparse growth of sagebrush. The river is bordered with a growth of thinly scattered pines and quaking asps. In the mountains, on either side, are stratified limestones, which rest on the gneissoid rocks we observed in the canyon. Scattered over the hills and through the valleys, I found many beautiful specimens of chalcedony and chips of obsidian. Many of the chalcedonies were geodes, in which were crystals of quartz. Others contain opal in the center and agate on the exterior, and still others have on the outside attached crystals of calcite. A short distance above the canyon, we came to Cinnabar Mountain, so named from the color of some of its rocks, which have been mistaken for cinnabar, although the red color is due to iron. Here we encountered what is called the Devil's Slide. It consists of two masses of rock in almost vertical position, perfectly defined as two walls. They are about 50 feet in width each and 300 feet high, reaching from the top of the mountain to its base. They are separated from each other about 150 feet, the intervening softer material having in the lapse of time been washed away. The right-hand mass is a whitish quartzite, while the left-hand one is a dike of greenish porphyritic trachyte, in which the crystals of feldspar are thickly disseminated. Parallel with these two principal walls are many more ridges of quartzitic and slaty nature, none of which equal them in magnitude. They are all nearly at right angles to the strata of limestone, which lie on either side. In a space to the right of the main ridge, there is a broad red band reaching from the top to the bottom of the mountain. It is caused by the sliding of ferruginous limestone and clay. It is about 20 feet wide and distinctly outlined. These ridges must have been forced into their present position when the strata above were horizontal. That there has been a terrible convulsion here in the past is proved a few miles farther on, where the strata of limestone are so contorted that, within the space of 200 feet, they dip in 3 different directions. In the limestone, there was an abundance of crystals of calcite. Some 8 or 10 miles farther on, we reached Gardner's River, a stream emptying into the Yellowstone just as the latter emerges from a canyon. Here we left the Yellowstone to visit some hot springs about 4 miles above the junction of the two streams. We soon came to the evidences of hot springs in the calcareous deposit, beneath which the warm water escaped into the river. Passing a number of hot springs, we began the ascent of a steep hill, passing over the deposit, which gave forth a hollow sound beneath our horses' feet. Suddenly we came in full sight of the springs. We were totally unprepared to find them so beautiful and extensive. Before us lay a high white hill, composed of calcareous sediment deposited from numerous hot springs. The whole mass looked like some grand cascade that had been suddenly arrested in its descent and frozen. Our examination, we found that the deposit extended for some 2 miles farther up the gorge, and below reached to the edge of the river, occupying altogether about 3 square miles, although the greater part of it is now in ruins and overgrown with pines. Still, the outlines can be very distinctly traced. The principal mass is arranged in a series of terraces, one above the other, each being composed of beautiful basins, semicircular in shape and having regular edges, with exquisitely scalloped margins. Their size varies, but will average 5 by 8 feet. They are filled with water of different temperatures, from cold to the boiling point. The color of the sediment is for the most part white, although here and there are tinges of yellow where sulfur predominates, and red and pink where there is iron. The weathering of those parts in which the springs are long extinct has caused it to assume a grayish appearance. The main springs are situated on a terrace about halfway up the mountain and cover an almost circular space of about 200 yards in diameter. The color of the water here is almost indescribable, being the purest azure. From these springs, clouds of steam are always rising, and the water is always bubbling and seething in its vast cauldron-like basin. The water flowing thence proceeds downward from terrace to terrace until it reaches the lowest, considerably cooled. The springs in the center of the main basin are probably all at the boiling point, although we were unable to determine their temperatures as they were beyond our reach. The temperature of the hottest we were able to determine was 162 degrees Fahrenheit. The terrace immediately above the main basin is bordered by a long rounded ridge with a fissure extending its whole length. From this fissure, nothing but hot vapors and steam escape. Its interior is lined with beautiful crystals of pure sulfur. The bubbling and gurgling of the water far beneath could be distinctly heard. Back of this ridge were two small geyser-like jets of water, which rose to the height of 3 feet intermittently. Farther up the gorge, about 1,000 feet above the level of the river, we discovered two mound-like formations, the largest of which was about 20 feet in height and 50 feet long by 30 feet wide. The other was only about 5 feet high. From the top of these, the water spouted to the height of 4 or 5 feet, each geyser spout proceeding from a small conical mound about a foot in height and 8 inches in diameter at its base. Breaking one of these cones, the tube through which the water came was found to be very small, only about 1/4 of an inch in diameter, while the remainder of the cone was composed of layer upon layer of sediment deposited by the overflowing water. Near these mounds there is a sulfur spring emitting a considerable quantity of sulfuretted hydrogen. On the lower terrace, the water has spread out more and formed shallower basins. Here there are also some remarkable formations, high chimney-like masses of the sediment composed of layer upon layer which, in the lapse of time, has become very hard. One of the most curious of these, the Liberty Cap, named from its shape, is about 45 feet high and 15 feet thick. It is altogether likely that these have once been veritable spouting geysers, for they are analogous in structure to the smaller active ones found higher up the valley. They became so high, however, that the pressure of the column of water was too great for the boiling point to be attained in the depths below. Then the eruptions ceased, and the spring gradually became extinct, leaving these masses stand as monuments of their former power. The temperature of the water near the river is 120 degrees Fahrenheit. In some springs a little higher up, 130 degrees Fahrenheit, and on the lower terrace, 155 degrees Fahrenheit. Still a little higher, there is a boiling spring, 162 degrees Fahrenheit. On the second terrace, the temperature varies from 142 degrees Fahrenheit to 162 degrees Fahrenheit. On the third, or main terrace, it is from 155 degrees Fahrenheit to 162 degrees Fahrenheit, and on the next, where the small geysers are, it is from 156 degrees Fahrenheit to 162 degrees Fahrenheit. At the two mounds high up the valley, it is from 142 degrees Fahrenheit to 143 degrees Fahrenheit, while in the sulfur spring near them, it is only 112 degrees Fahrenheit. The average temperature of the atmosphere was 63 degrees Fahrenheit. The majority of the springs give off sulfuretted hydrogen gas, some being more strongly impregnated than others. The water contains sulfuretted hydrogen, sulfate of magnesia, and carbonates of lime, soda, and potassa. Whence do these springs obtain the lime, which is so abundant in their composition? I think from the passage of the water through the strata of limestone. Even the igneous rocks, which are mostly porphyritic trachytes of a light gray color, contain a considerable percentage of lime, and some of the piques I obtained were coated with crystals of calcite. To the west of the hills, there are high volcanic peaks on the summits of the hills, whose elevation is considerable. To the east, bordering Gardner's River, there is a remarkable wall composed of limestones and sandstones capped with a layer of basalt. Indeed, the whole valley is shut in by high hills. In New Zealand, there is a hot spring formation which resembles this very much in appearance, although the constitution of the sediment is different. In New Zealand, silica predominates. Here, carbonate of lime appears in the greatest quantity. The white deposit contains carbonate of lime, chloride of calcium, carbonate of magnesia, carbonate of strontia, carbonate of soda, carbonate of potassa, sulfate of magnesia, sulfur, silica. I insert Hochstetter's description of the New Zealand formation to show how similar it is in appearance. First of all is Te Tarata, signifying tattooed rock, at the northeast end of the lake, Rototomahana, with its terraced marble steps projecting into the lake, the most marvelous of the Rotomahana marvels. About 80 feet above the lake, on the fern-clad slope of a hill, from which in various places hot vapors are escaping, there lies the immense boiling cauldron in a crater-like excavation with steep, reddish sides 30 to 40 feet high, and open only on the lakeside toward the west. The basin of the spring is about 80 feet long and 60 wide, and filled to the brim with perfectly clear, transparent water, which in the snow-white encrusted basin appears of a beautiful color like the blue turquoise. At the margin of the basin, I found a temperature of 183 degrees Fahrenheit, but in the middle, where the water is in a constant state of ebullition to the height of several feet, it probably reaches the boiling point. Immense clouds of steam, reflecting the beautiful blue of the basin, curl up, generally obstructing the view of the whole surface of water. But the noise of boiling and seething is always distinctly audible. The reaction of the water is neutral. It has a slight salty, but by no means unpleasant taste, and possesses in a high degree petrifying, or rather encrusting qualities. The deposit of the water is like that of the Iceland springs, silicious, not calcareous, and the silicious deposits and incrustations of the constantly overflowing water have formed on the slope of the hill a system of terraces, which, as white as if cut from marble, present an aspect which no description or illustration is able to represent. It has the appearance of a cataract plunging over natural shelves, which as it falls is suddenly turned into stone. The silicious deposits cover an area of about 3 acres of land. For the formation of those terraces, such as we see them today, doubtless thousands of years were required. Forbes, judging by the thickness of the silicious deposits on the Great Geyser of Iceland, which he estimates at 762 inches, and by the observation that an object exposed to the discharge of the geyser water for the space of 24 hours is covered with a sheet of paper thickness, has calculated the approximate age of the Great Geyser at 1,036 years. Similar calculations might be made also with regard to the Te Tarata fountain by examining the thickness of the silicious incrustations. The flat, spreading foot of the terraces extends far into the lake. There the terraces commence with low shelves containing shallow water basins. The farther up, the higher grow the terraces, 2, 3, also some 4 and 6 feet high. They are formed by a number of semicircular stages, of which, however, not 2 are of the same height. Each of these stages has a small raised margin from which slender stalactites are hanging down upon the lower stage, and encircles on its platform 1 or more basins resplendent with the most beautiful blue water. These small water basins represent as many natural bathing basins, which the most refined luxury could not have prepared in a more splendid and commodious style. The basins can be chosen shallow or deep, large or small, and of every variety of temperature, as the basins upon the higher stages, nearer to the main basin, contain warmer water than those upon the lower ones. Some of the basins are so large and so deep that one can easily swim about in them. In ascending the steps, it is of course necessary to wade in the tepid water, which spreads beside the lower basins upon the platform of the stages, but rarely reaching above the ankle. During violent water eruptions from the main basin, steaming cascades may occur. At ordinary times, but very little water ripples over the terraces, and only the principal discharge on the south side forms a hot, steaming fall. After reaching the highest terrace, there is an extensive platform with a number of basins, 5 to 6 feet deep, their water showing a temperature of 90 degrees Fahrenheit to 110 degrees Fahrenheit. In the middle of this platform, there arises, close to the brink of the main basin, a kind of rock island about 12 feet high, decked with manuka, mosses, lycopodium, and fern. It may be visited without danger, and from it the curious traveler has a fair and full view into the blue, boiling, and steaming cauldron. Such is the famous Teterata. The above is an almost perfect description of the springs at Gardner's River. We have the same beautifully clear blue water, the terraces and basins, even to the stalactitic processes hanging from the latter. We have also an upper platform or basin with the main springs, from which continual clouds of steam are rising. The lower terraces are also shallower, and their basins filled with cooler water. We have the same form of natural bathing basins of a pure white color. To these latter, some of our party gave the names of Jupiter's Baths and Diana's Pools. The differences are these. In New Zealand, the deposit is mainly silicious. Here it is calcareous. In New Zealand, the water is neutral. Here it is alkaline. In New Zealand, the main spring is probably a vast geyser. At Gardner's River, it is not likely, at the present time at least, that it is a geyser, for the main springs are so large that even if there is a tube at the base supplying one of the conditions for a geyser, the pressure of the water would prevent any eruption unless it should take place at extremely long intervals. If so, the display would be grand beyond all precedent. It is likely, however, that sometime in the past it has fulfilled all the conditions of a geyser. The deposit at Gardner's River is much more extensive than that of the Teterata. We left the hot springs on the 24th of July. Proceeding down the hill, we crossed the 2 branches of Gardner's River and wound our way up the right bank of the east fork of the river. Our course was along the steep side of the mountain over sandstones, which were capped with a broad plateau of basalt, fragments of which were strewn along our trail. After about 4 miles of steady climbing, we reached the top of the valley. Here the basaltic layer extends across the gorge, forming an abrupt perpendicular wall, broken only on the side opposite that on which we were. Here the water rushes down in a beautiful fall, its beauty half hidden by the dense foliage of the pines which surround it. Ascending upon the basaltic platform and looking back, the scene was grand. High mountains in all directions, their rounded forms relieved by numerous sharp peaks, formed the background, while in the foreground beneath us lay the valley through which we had come. Central feature of the whole scene was the hot spring formation, its pure white color contrasting strongly with the green of the surrounding vegetation. Turning again, the scene in front was different. Although there was less of grandeur, there was more of beauty. Before us lay low, rolling hills clad in bright verdure and dotted with scattered groups of pines. About a mile farther on, we passed a second cascade. The water flows down a bed of basalt, which is inclined at an angle of about 45 degrees, arranged in a series of ledges reaching from the top to the bottom, a distance of about 200 feet. These ledges cause the water to be broken into foam, giving it, at a distance, the appearance of a mass of snow. Bordering the cascade are chimney-like masses of red igneous rock. The horizontal and vertical fissures in it make the resemblance to masonry very striking. Near here, we obtained some good specimens of silicified wood. The following day, we reached the Yellowstone River at the junction of its two forks. Here we encountered gneissic rocks, and scattered over the valley were numerous granitic boulders, their rounded form plainly indicating that they must have been carried some distance before being deposited in their present position. Above the junction of the two forks, the main branch of the river emerges from a canyon, which is over 500 feet in depth, its walls being almost perpendicular. The walls have a capping of basalt, the columnar form of which is very distinct, especially at Column Rock near the mouth of Tower Creek. Tower Creek is a swift mountain torrent, which, after rushing through a narrow gorge with steep and often precipitous sides, suddenly dashes over a ledge of rock and falls perpendicularly a distance of 156 feet into a rounded basin which the water has cut out of the solid limestone. The width of the fall is about 20 feet. Reaching the bottom, the water hurries on through a short canyon to the Yellowstone River. Upon the limestones rest volcanic rocks, trachytic in nature. These have been so eroded by the action of the torrent as to leave tower-like masses 100 feet in height, standing isolated on the edge of the creek. Two of these columns stand, one on either side of the fall, at its edge. They are yellowish in color from the presence of sulfur, and the exposure to the weather has rendered them very friable. The bank of the Yellowstone, immediately opposite the mouth of Tower Creek, is about 600 feet high and has two rows of basaltic columns, each one of which is about 25 feet in height and 5 feet in diameter. Between these two layers, which are 200 feet apart, are beds which seem to have a large amount of sulfur in their composition from their bright yellow color. We were not able, however, to cross the river to determine it. There are also, doubtless, numbers of hot springs scattered along the edge of the river on that side. A few yards above the mouth of Tower Creek, on a small stream emptying into the Yellowstone River, there was a hot spring and a number of vent holes giving off sulfurated and carbureted hydrogen. The main spring is only 2 feet in diameter and about 18 inches deep. It is close to the edge of the creek and gives off sulfurated and carbureted hydrogen. The basin of the spring is a black, clayey material. Its temperature was 127 degrees Fahrenheit. The water was acid in reaction and contains sulfate of iron and alumina, abundant, sulfate of magnesia, sulfate of lime, oxide of iron, free sulfur, chloride of calcium, soda and potassa, trace. There is in the ravine in which the creek is situated a deposit of sulfur, and also near the spring a deposit white in color containing sulfur, iron, alumina, silica. In the bed of the stream there is an abundant deposit of sulfur and also a black carbonaceous material. The sulfurous odors emanating from the ravine are so strong as to be recognized at a considerable distance from it. A short distance above Tower Creek, we ascended a peak called Mount Washburn, whose summit is composed of a light gray trachytic rock containing acicular crystals of hornblende. On the sides of the mountain we found large pieces of chalcedony and agate. Near the base of the mountain there are situated quite a number of sulfur and mud springs. A specimen from one of the latter was of an almost black color, and when dry was covered with a white efflorescence. It contained sulfate of alumina and iron, sulfate of magnesia, sulfide of calcium, sulfur, silica. Our next camp was near the Great Fall of the Yellowstone. It is at the head of the Grand Canyon, a gorge averaging about 1,000 feet in depth, which the water has cut through the volcanic rocks. These rocks are mostly trachytes of a white or gray color, on top of which there is a layer that is basaltic in its character. In many places they become rhyolitic and contain crystals of sanidine, very abundantly distributed through them. In one place I found a perlite-like trachyte porphyry containing small feldspathic balls, spherulites, with a radiated fibrous structure mixed with small pieces of obsidian. Some of the rocks are colored by iron, which has been deposited from hot springs. In other places, there is an infiltration of sulfur, which gives them a bright yellow color. There are still some warm springs on the edge of the river, and at the only place we were able to get to it, there were 3 or 4 small springs giving off carbonic acid gas, which has caused an abundant deposit of sesquioxide of iron about them. Having no thermometer with us, we were unable to determine the temperature of the water, but it could not have been much over 90 degrees. It contained a white organic material. Passing the upper fall, after a ride of about 18 miles, we reached Crater Hills. These consist principally of 2 conical hills about 150 feet in height. There are several other hills which are smaller. They are all made up in part of hot spring deposit and a white trachytic tufa. All about the hills there is an extensive deposit, mostly siliceous, forming a crust which often breaks through while walking over it. It is lined with beautiful crystals of sulfur. At the base of the hills there is a large boiling sulfur spring in which the water is constantly agitated, rising to the height of 3 and 4 feet. It is about 12 feet in diameter and encircled by a collar-like rim, which is beautifully encrusted. It consists principally of silica and sulfur. In the stream proceeding from the spring, there is quite a deposit of sulfur. The water contains sulfur, very abundant, alumina, silica, lime, trace, iron, trace, chlorine, sulfuric acid. Its temperature is 1,831 degrees Fahrenheit. About 300 feet west of this spring there is a steam jet, which was named the locomotive jet from the noise made by the steam in escaping. The temperature there was 191 degrees Fahrenheit. On the sides of the hills there were many more steam jets, in which the highest temperature attained was 1,971 degrees Fahrenheit. To the southeast of the boiling sulfur spring is a large, turbid spring about 35 feet in diameter. Its contents consisted of a very thin bluish mud containing sulfate of alumina of iron, chloride of magnesium, sulfate of alumina, free sulfur, silica, and having a temperature of 163 degrees Fahrenheit. It was acid in reaction and tasted strongly of alum. About 300 yards south from the main spring, there is a collection of mud and sulfur springs. The principal mud spring in this group contains a thick blue mud. It has the consistency of paint, and the steam, in escaping from it, does so with a thud-like noise, and at times projects the mud to a considerable height. Its temperature is 1,881 degrees Fahrenheit. The mud has a strong alum taste, is acid in reaction, and contains sulfate of iron and alumina, sulfate of magnesia, chloride of magnesium, alumina, sulfur. Near this latter spring there is another, which was named the foam spring. The water is very turbid, and floating on its surface there is a greenish, sandy, foam-like material consisting of sulfur, very abundant, silica, oxide of calcium, sulfate of alumina. It is in a constant state of agitation. There are many other sulfur and mud springs here which resemble one another closely. All the mud springs are impregnated with alum, and the stream flowing away from the hills is called Alum Creek, the water of which is strongly astringent. The alum is an iron alum. Leaving the hills, we found camp, situated on the bank of the Yellowstone River at a place called Mud Volcanoes. Here again was a large collection of mud and sulfur springs. Immediately back of camp were 2 crater-like mud springs or volcanoes about 10 feet in depth, at the bottom of which the escaping steam kept the thick blue mud in a state of violent agitation, sometimes throwing it to the height of 15 or 20 feet. This mud contained sulfate of iron and alumina, sulfate of magnesia, chloride of magnesium, alumina, sulfur, silica. Near these mud craters, there were also some alum pools containing alum and sulfur. On the edges of these pools, there were a number of holes, from which there was a bubbling of water that flowed into the springs. Upon ascending the hill, at whose base these springs were situated, we could see immense volumes of steam rising toward the southeast. Proceeding in that direction about 400 yards, we came to a sort of a cave in a sandstone rock. The entrance is about 15 feet high, and it gradually slopes inward for about 20 feet. At this point, at regular intervals of a few seconds, there bursts forth a mass of steam with a pulsation which shakes the ground, while a stream of clear water flows from the mouth of the cavern. Its temperature was 184 degrees Fahrenheit. The water had a very faint alum taste and gave off a slight odor of sulfurated hydrogen. This spring we named the Grotto. A little farther on, after passing a large, muddy sulfur pool of about 20 feet in diameter, we found on the side of the hill a huge mud crater. Its orifice is circular, and from it there escapes a dense volume of steam, obscuring for the greater part of the time the view of the boiling mass of mud, which is 20 feet below the surface. It was too deep for us to determine its temperature. The mud seems to be very thin and of a blackish color. Some of the mud from the rim of the crater contains alumina and silica, with a little iron, lime, soda, and potassa. It is probably a true mud geyser, for the appearance of the crater and the trees around it would indicate that at times it ejects its contents to a considerable height. The trees within 200 feet of it are coated with dried mud even to their topmost branches. During our stay, however, it had no eruption. About 300 yards southeast of this crater, we discovered another muddy geyser. The basin of this geyser was about 50 feet in diameter and situated in a basin circular in shape, containing two other springs. Its temperature was 191 degrees Fahrenheit. The trapper who was with us and who had visited the place before assured us that about 6:00 p.m. it would commence spouting. We waited somewhat incredulously, for the spring was quite placid. Soon, however, there began a slight bubbling in the center, and the water began to rise gradually in the basin until suddenly it was thrown into violent agitation, the contents becoming very muddy. Immense volumes of steam escaped, throwing the water to the height of 20 feet. The eruption lasted about a quarter of an hour, when it ceased as suddenly as it began, and the surface of the water was more placid than before. This eruption took place 8 times in 26 hours. These salses, or mud volcanoes, are known to all volcanic regions. They are found in South America, in Italy, in Java, in New Zealand, and in Iceland. We found them always where the water was obliged to pass through a bed of clay. In the last group I have described, in one case, that of the Grotto, the water came through sandstone and was perfectly transparent and clear. Had it been situated in a bed of clay, it would probably have been a mud spring. In all of these, we found sulfuretted hydrogen gas to a greater or less degree, and they were all impregnated with alum. The sulfuretted hydrogen is probably decomposed, losing its hydrogen. The sulfur, becoming oxidized, unites with the iron and alumina found in the clay and forms the sulfate of alumina and iron. There were also in this group a number of springs that were extinct. Between the active springs, in which the mud was very thin, and those which were extinct, nothing remaining save the hardened clay, there were springs of every grade, as considered in reference to the consistency of their contents. The water, in the lapse of time, becomes less and less, either by finding new channels or more likely by evaporation. The mud becomes thicker and thicker until finally all the water disappears, leaving merely vents through which steam escapes, and after a while even these become extinct, and the orifices become clogged up with detritus. All hot springs and salsas are the evidence of languishing volcanic action. We reached Yellowstone Lake on the 28th of July, and on the 31st, a small party of us left the lake to visit the Geyser region of the Firehole River, the headwater of the Madison. The remainder of the party were to move camp some 28 miles farther to the south, where we would join them in about a week. After a hard day's travel of 31 miles through heavy timber, we reached the headwaters of the East Fork of the Madison, or Firehole River. The mountain range over which we passed was igneous, and in many places masses of pure obsidian were observed. We passed by a number of fumaroles from which steam and gas were escaping, while all about them was the white siliceous deposit, mingled with sulfur and iron, indicating the past existence of hot springs. The water in the stream on whose bank we were encamped was quite warm, although in the morning the mercury in the open air was down almost to the freezing point. About a mile and a half from our camp were some hot springs, covering an area of about 200 square yards. Their temperature varied from 128 degrees Fahrenheit to 1,990 degrees Fahrenheit. The deposit of some of the springs was calcareous. Leaving here, we proceeded downstream, passing a number of hot springs, some of which were noticeable from the iron deposited in their basins. Their temperatures were from 142 degrees Fahrenheit to 1,920 degrees Fahrenheit. The iron was deposted on an organic material, which was abundant in springs of low temperature. Just before going into camp, we passed 4 hot springs of considerable size. They were each situated in the center of a slightly elevated mound, which sloped gradually from the edge of the spring until lost in the general level. The first was 4 feet in diameter, having a temperature of 162 degrees Fahrenheit. The second was 2 feet in diameter, its temperature being 170 degrees Fahrenheit. The third was only about a foot in width and reached 174 degrees Fahrenheit. The fourth and largest was somewhat irregular in shape, being about 15 feet in length and 5 feet in width, the thermometer here recording 156 degrees Fahrenheit. A short distance from these springs was a small mud spring about a foot in diameter. At the bottom of it, about a foot from the surface, was an agitated mass of thick, bluish mud, having a temperature of 190 degrees Fahrenheit. Our camp on the evening of August 1st was on the right bank of the East Fork of the Madison, or Firehole River, in the lower geyser basin of the Firehole. We divide the springs and geysers of this basin into 7 principal groups for the purpose of description. Immediately opposite our camp along the river, occupying a space about a quarter of a mile wide and nearly 2 miles long, was the first group. Here we recorded the temperatures of 67 springs. The lowest was 106 degrees Fahrenheit, the highest 198 degrees Fahrenheit, and the average 159 degrees Fahrenheit, more than 1/2 being above 160 degrees Fahrenheit. The temperature of the air was about 50 degrees Fahrenheit. Some of these were geysers, with small tubular orifices, projecting the water from 2 to 5 feet. There were also some large, tranquil springs or cisterns with beautifully encrusted siliceous basins, containing water whose tint was an exquisite blue. One of these, whose basin was encrusted with successive ridges, along each of which there was a line of the colors of the spectrum, we called the prismatic spring. The majority of them were simply siliceous springs. A few, however, were chalybeate. The siliceous sinter, geyserite, which was very abundant, contained a trace of lime, iron, and magnesia. In some of the springs of low temperature, there was a leathery-like organic material of a red color. The following day, we moved our camp nearer the center of the basin, about 2.5 miles farther south. On our way, we passed between 2 conical, isolated, trachytic hills. The space between our two camps is filled for the most part by the center, and where there is none, the ground is marshy. A small stream flowed past our camp, conveying the water from the springs to the river. Immediately in front of our camp, about 800 yards distant, was the second group, composed principally of geysers. They occupied an area of about 3/4 of a mile. We recorded here the temperatures of 16 springs, 1/2 of which were over 190 degrees Fahrenheit. The lowest was 140 degrees Fahrenheit, and the highest 196 degrees Fahrenheit, the average being 183 degrees Fahrenheit. The temperature of the air was about 55 degrees Fahrenheit to 60 degrees Fahrenheit. One of the geysers, from the peculiar noise it made, was called the thud geyser. There were many of them that threw the water from 5 to 10 feet high. In the cool, frosty morning, the basin resembled some manufacturing center, as clouds of steam could be seen in all directions. The principal geyser of this group was situated on the slope of a small hill and was about 20 feet in diameter. The rim is about 5 feet wide and 5 feet high. It is composed of geyserite of a grayish color and is full of deep pockets, which contain balls of geyserite about the size of walnuts, each one being covered with little rosette-like formations. The column of water thrown out by this geyser during its eruptions is very wide and reaches the height of 50 feet. Near it, we obtained some pieces of wood, which were coated with geyserite of a delicate pink tinge. The silica had thoroughly penetrated the woody fiber. We found also some pine cones coated in the same manner, forming beautiful specimens. A few yards back of the geyser were 3 large mud springs, in one of which the mud was red, in another white, and in the third pink. They were all in agitation, and the jets of steam escaping caused the mud to assume the form of small conical points throughout the basins. They were situated in a bed of clay, the red color being due to iron. Below these latter there were some chalybeate springs, the bright red iron deposit of which had spread over a considerable area and formed a glaring contrast with the white color of the siliceous material. About 3/4 of a mile to the southeast of this group is the third group, situated at the northwestern base of a spur of the mountains and extending up a ravine a distance of 1,000 yards. They occupied a space of about 500 yards in width. One of the springs, from its shape, we named the Fisher Spring. We found here 3 sulfur springs, the only ones in the region. The amount of sulfur present, however, was not very great. Their temperatures were respectively 138 degrees Fahrenheit, 154 degrees Fahrenheit, and 196 degrees Fahrenheit. In this ravine, we took the temperatures of 20 springs, averaging 158 degrees Fahrenheit. The lowest was 130 degrees Fahrenheit, and the highest 196 degrees Fahrenheit. About the center of the group was a small lake, 600 feet long and 150 feet wide, near the eastern shore of which there was a geyser, which spouted very regularly to the height of 15 or 20 feet. A short distance southeast of the lake, we found an iron spring, which was surrounded by an abundant deposit. Its temperature was 1,600 degrees Fahrenheit. West of the lake were 2 geyser cones, about 18 inches high and 12 inches across at their bases, and from the top of these the water emerged. They were encrusted with a cauliflower-like formation, and near them in a fissure we obtained balls of geyserite coated in the same manner. The stream flowing from the lake is well filled with a luxuriant growth of confervoidea. About 1,000 yards farther south is the fourth group. The ravine in which they are situated is about 1.5 miles long and 300 yards wide. Of the many springs and geysers which it contains, we took the temperature of 42, varying from 112 degrees Fahrenheit to 198 degrees Fahrenheit. The average temperature was 179 degrees Fahrenheit, the temperature of the air being about 60 degrees Fahrenheit. Just before entering the ravine, we passed by a large cone, about 25 feet in height, from the top of which steam was escaping. It is probably a geyser, although during our stay it did not have an eruption. At the mouth of the ravine, we found the principal geyser of the group. Its basin was circular and about 60 feet in diameter, although the spring itself, which is in the center, is only about 15 or 20 feet in diameter. The encrusted margin is full of sinuses, filled with hot water, which falls into them whenever the geyser is in operation. These pockets contain also smooth, rounded pebbles of geyserite, varying in size from that of a pea to a large-sized walnut. They have been rounded by the action of the water. The water in the spring of the geyser was of a blue color and constantly in agitation, though more violently so just before spouting. The column of water projected reaches the height of 100 feet and is accompanied by immense clouds of steam. Near the upper end of the ravine was a spring, about which the deposit, instead of being white, was black. In some of the springs we found butterflies which had fallen in and been scalded to death, and on taking them out we found them coated with silica, thus commencing to undergo petrifaction. About 1,000 yards west of our camp, on the banks of the Firehole River, was the fifth group, the largest of all, covering a space of nearly a square mile and comprising a large number of springs and geysers. We recorded the temperature of 95, more than one-half of which were over 180 degrees Fahrenheit. They varied from 112 degrees Fahrenheit to 196 degrees Fahrenheit, the average being 172 degrees Fahrenheit. The air at the time of observation was 700 degrees Fahrenheit. One of the springs, from its resemblance to a shell, we named the Conch Spring. One geyser resembled a fortress with numerous portholes looking toward the river. Its temperature was 196 degrees Fahrenheit. In the river were several small islands containing geysers. Opposite one of them, on the edge of the river, was a horn-like geyser cone, which we named the Horn Geyser. Another we called the Cavern. There are also a number of fumaroles, or vent holes, from which steam constantly escapes. Near the northern end of the group, the river flows close to the base of a small wooded hill, along the edge of which were some mud springs and mud geysers, the mud varying in color, being white in some and blue in others. In some it was very thick, and in others almost as thin as water. On ascending the hill after passing through the woods, we came to a dozen or more interesting mud springs. They were almost all situated at the bottom of large, funnel-shaped craters, of about 20 feet diameter at their mouths. The mud in most of them was very thick and of a white or grayish color, and the steam in escaping did so with a dull, thud-like noise, throwing back the mud in forms resembling the leaves of a lily. Near these, there were some small mud cones, from the top of which there was steam escaping. Breaking them open, they were found to have veins of sulfur and iron running through them. About 2 miles southwest of the last mentioned group is the sixth group, situated on a small stream flowing into the Firehole. They are in a large, open, prairie-like valley, which is for the most part marshy. At the head of the valley, there is a beautiful cascade. We took the temperatures of 34 springs, varying from 106 degrees Fahrenheit to 198 degrees Fahrenheit, the average being 184 degrees Fahrenheit. One of the springs was strongly chalybeate. The seventh group is on the Firehole River, about 2.5 miles south from our camp. Here we met with the largest spring we had yet encountered. It was over 400 feet in diameter, and the center extended in overlapping layers for a considerable distance around it. Below this, about 600 feet from the river, was a second huge spring, which we named the Cauldron. The level of the water in it was 20 feet below us, and the view of it obscured by the dense clouds of steam rising from it. The glimpses we got revealed that it was of a beautiful blue color. One side of the wall was broken down, and thence the water flowed into the river through a number of streams, forming a cascade, whose beds were lined with the sesquioxide of iron. We took the temperatures of 20 of the springs and found the average to be 184 degrees Fahrenheit. The lowest temperature was 132 degrees Fahrenheit, and there were but 2 other springs below 173 degrees Fahrenheit. One half of the springs were above 190 degrees Fahrenheit, the highest being 196 degrees Fahrenheit. The air was about 700 degrees Fahrenheit to 76 degrees Fahrenheit. The lower Geyser Basin comprises an area of about 30 square miles, and the springs whose temperatures we took are but a small part of the whole number. They are divisible, like those of Iceland, into 3 classes. 1. Those which are constantly agitated or boiling. 2. Those which are agitated only at particular periods. 3. Those which are always tranquil. In the geysers, the water is usually placid until within a short time of the eruption, when it begins to bubble and there is an escape of steam, the water rising gradually in the basin until suddenly it is projected into the air. We left our camp in the lower basin about noon of the 4th of August, proceeding up the Firehole River, and in the evening pitched our tents in the upper basin. This basin is not so large, occupying a space of only about 3 square miles and containing a less number of springs. They are, however, much more active, and their craters are more beautiful, interesting, and larger. The majority of the springs and geysers are near the river, extending along it on both sides for about 3 miles. Many of them were named by the party under Langford and Doane, who visited them in 1870. Soon after getting into camp, we were treated to an exhibition that was truly wonderful. Immediately opposite us, at the base of a small hill, a geyser threw a column of water to the height of over 200 feet from the earth, which shook as the water fell back into its basin. It was accompanied with a vast quantity of steam. We gave it the name of the Grand Geyser. It had but one more eruption during our stay, and that during the next night, after an interval of 31 hours. The deposit throughout the valley is siliceous, as in the lower basin. We recorded the temperatures of 104 springs and geysers, and these were but a few of the whole number. Many of those not taken were too violently agitated for us to approach them with safety. Others were so large as to be beyond the reach of the thermometer. 2/3 of the temperatures taken were over 170 degrees Fahrenheit, the lowest being 113 degrees Fahrenheit, and the highest 196 degrees Fahrenheit. The temperature of the air was 67 degrees Fahrenheit. The principal geysers were named as follows: the Soda Geyser, the Fan Geyser, the Riverside, the Grotto, the Pyramid, the Giant, the Punch Bowl, the Grand Geyser, the Sawmill, the Castle, the Giantess, the Beehive, and Old Faithful. The Soda Geyser was 2 miles below our camp on the left bank of the river and spouted with great regularity every 10 minutes, throwing the water up 10 feet, resembling very much a soda fountain, whence its name. The Grotto Geyser was situated about 500 yards northwest from our camp. It consists of a mass of sinter 12 feet in diameter and 5 feet high, full of large, sinuous orifices from which the water is projected during an eruption. 400 feet southeast of the grotto is the Giant. The crater of this geyser is very rough and rises about 10 feet above the surrounding level. It is 8 feet in diameter at its base and 5 or 6 at the top. One side is somewhat broken down, allowing one to see the boiling water in it. It projects a column of water of about 5 feet in diameter to the height of 125 feet, the eruptions each lasting about 2 hours. Near the Grand Geyser, which was immediately opposite our camp, there was a small one, which we named the Sawmill Geyser. It threw a small stream to the height of 10 or 15 feet, almost uninterruptedly. Still farther up the river, and on the opposite side, is the Castle, the most beautiful of them all. It is situated in the center of a large, gently sloping mound of sinter, above which its crater rises about 20 feet. It is about 50 feet in length and beautifully encrusted with bead-like formations. The whole mass resembles some old castle that has been subjected to a bombardment. It has an eruption every few hours. Between the castle and the river is one of the large springs or cisterns so numerous throughout the region. It corresponds to the Laugs of Iceland, which sometime in the past have been geysers. This one is about 20 feet in diameter and is funnel-shaped. The edge is lined with a series of beautifully regular scallops. The water in this white, silicious basin is an exquisite tint, resembling the turquoise blue. This intense blue, however, is not peculiar to this region. It is noticed as well in New Zealand and in Iceland. The temperature of the water was 172 degrees Fahrenheit. At the head of the valley stands Old Faithful, so named for the regularity of its spouting, which takes place every 50 minutes, lasting about 10 minutes, the water reaching the height of 125 to 150 feet. Its crater is conical and 6 feet high. Near it there are 4 geyser cones, which are now extinct geysers. On the opposite side of the river from Old Faithful are the Giantess and Beehive, neither of which were seen in operation by us. Bunsen's theory of the geyser is the simplest and probably the most correct. It can be verified by experiment, and the facts observed by us sustain it. Briefly stated, it is this. The water deposits nothing except by evaporation, which takes place rapidly at the edges. Here, then, the silica, which is held in solution, is deposited and builds up the beautiful tube and basin of the geyser. Bunsen succeeded in determining the temperature of the geyser tube from top to bottom a few moments before eruption, and found that at no part of the tube was it at the boiling point. How, then, does the eruption take place? It is always noticed that before an eruption the water rises in the tube. The higher we go in the tube, the lower is the point at which the water boils. Suppose the column of water is elevated by the entrance of steam through ducts at the bottom of the tube. The water, which at a certain point was near the boiling point, is elevated to a part of the tube where the boiling point is lower than the temperature it has. There is therefore an excess of heat. This excess of heat is used in generating steam. The water is elevated higher. More steam is formed, and suddenly the water above is thrown into the air, mingled with clouds of steam, and we have the geyser in action. The water has to be very near the boiling point before an eruption can take place. In the firehole geysers, we notice that just before an eruption, the water rose gradually in the basin, and that there were occasional attempts at eruptions which failed, preceding the actual eruption. A specimen of the water brought back was as clear as when bottled at the geysers, showing no deposit whatever. There was not sufficient for a quantitative analysis. It contained 8,350 milligrams of solid matter to the liter, consisting in the main of silica. Chloride of lime and sulfate of magnesia were present in small quantity, and there was also a trace of iron present. The glaring white deposit, which extends over both the upper and lower basins, is principally geyserite, a variety of opal. The forms it assumes here are similar to those found in Iceland. The specimens vary in color, form, and texture. The majority are of an opaque white or grayish color. In the lower basin, some pink specimens were obtained, which are translucent. Other specimens are of a greenish gray. Some of the white pieces were subtranslucent, others were pearly and enamel-like. Specimens from the geyser cones have generally a cauliflower-like form and break very easily. Others are beaded, and still others covered with small stalagmitic processes. The texture varies from porous to compact, and some pieces are very easily reduced to powder. The majority of the deposit which extends through the basins is porous and arranged in layers. The geyser cones are generally very compact and very often have an enamel-like coating. From some of the springs, masses were obtained that are filamentous and stalactitic. Some pieces seem as though the surface had been enameled and then suddenly allowed to contract, leaving small, irregularly shaped plates of enamel attached to the main mass by pedicles. In the lower basin, we found smooth balls, which, on being broken, were found to be composed of concentric layers of geyserite of a homogeneous structure. Others, which were beaded or otherwise fantastically fashioned on the outside, were found to be very irregular in their structure. The latter were generally of a pink color. On the 6th of August, we bade farewell to the Geyser Basin and started on our way toward the Yellowstone Lake to rejoin the main party. Our way led upward through dense timber, and after traveling 8 miles, we reached the summit of the first ridge of mountains separating us from the lake. The rock at the summit was a porphyritic obsidian containing large crystals of feldspar thickly disseminated through it. We now began to descend, and at the foot of the mountain passed by Madison Lake, which is about 5 miles in diameter. It is heart-shaped. The sand on its shore is composed of finely broken-up obsidian intermixed with chips of chalcedony and red jasper. We were obliged to go into camp at night without having reached the lake, whose shore, however, we reached the following morning, to find ourselves about 3 miles below camp. Our camp was situated near a large collection of hot springs and mud geysers. The former varied in temperature from 115 degrees Fahrenheit to 191 degrees Fahrenheit, averaging 16,640 degrees Fahrenheit. The latter ranged from 132 degrees Fahrenheit to 190 degrees Fahrenheit, the average being 15,540 degrees Fahrenheit. The temperature of the air during observation was about 659 degrees Fahrenheit. The water of the springs contains silica, iron, alumina, soda, potassa, sulfuric acid. Its reaction was neutral. In some of the springs of low temperature, there was a red gelatinous organic growth. One of the most curious of the springs was situated in the midst of the lake, close to the shore. Its basin was about 3 feet above the surface of the lake and was composed of a white deposit containing a large percentage of silica, it being of the same character as the deposit about the springs on the shore. The water in this basin, which had the shape of a truncated cone, had a temperature of 160 degrees Fahrenheit. The mud springs, or geysers, for they threw the mud out to the height of 3 and 4 feet, were situated in a bed of clay. Their contents consisted of a rather thick mud of an extreme degree of fineness and of a beautiful pink color. It contained iron, abundant, alumina, abundant, lime, silica. Our party again divided, one portion returning to the permanent camp to bring up further supplies, another to make the survey of the lake in the boat, while the remainder of us started on the 9th of August, on our way around the lake by land. In the evening, after a ride through low, marshy ground, we camped at the head of one of its southern arms, at the base of a large, reddish-colored mountain, which forms one of the prominent landmarks, being visible from all parts of the lake. The next day we crossed the mountain and pitched our tents on one of the small streams that contributes to form the Snake River. The following evening we reached Bridge Creek, or the Upper Yellowstone River, at the head of the southeast arm of Yellowstone Lake. Leaving here, we proceeded down the eastern shore of the lake, which we found to be not so thickly covered with timber as the western side, nor so marshy as the southern shores. After leaving the head of the lake, we made 3 camps before leaving it altogether. Back of our first camp, which was on a rocky bluff, there was a high ridge of igneous origin, composed mainly of volcanic breccia, in which I obtained good specimens of wood opal. Some of the pieces were enclosed in the center of a mass of the breccia, which seemed to have flown over it in a melted condition. Some of the specimens obtained were evidently the heart of the wood, the center of which contained chalcedony and crystals of quartz in fissures caused originally by the splitting of the wood. Our second camp was in one of the small prairies so numerous on this side of the lake. Here we were joined by the supply train and by the party in the boat. In the lake opposite to us was Promontory Point, a point of land running out into the water between the southeast arm and one of the southern arms of the lake. A piece of rock brought from it contained ram spar and crystals of calcite, the matrix being red from the presence of iron. Near camp were two high volcanic peaks, Mounts Stevenson and Doane. The summit of the former is composed of a light gray trachyte containing acicular crystals of hornblende. The rock is identical with that on Mount Washburn. Between our two camps was the site of an old hot spring basin, now extinct, to which was given the name of Brimstone Basin, from the sulfur which exists in it. The deposit, which is mostly of a white color, fills a valley that is about a mile in length and a quarter of a mile in width. It extends up the side of the mountain in deep ravines, in some of which there is a strong sulfurous odor, although the hot springs are all extinct. The water flowing from these beds is cold and impregnated with alum, which probably results from the water passing through the sulfur and clay beds. It is acid in its reaction. On the 19th of August, we moved our camp farther down the lake to Steamy Point. Just before reaching it, we passed a small group of hot springs and steam jets, which were a few yards from the shore. There was about them a deposit of sulfur, iron, and alum. One or two of the springs contain chloride of sodium. The average temperature of these springs was 1,831 degrees Fahrenheit, the highest being 198 degrees Fahrenheit, and the lowest 178 degrees Fahrenheit. Our camp was situated on a high bluff on the edge of the Eek. Near us there were two vents, from which the steam, in escaping, made a noise exactly like a large steamboat letting off steam. Whew! The volume of steam was very large, and the discharge constant. There were here also some small mud springs. Every night while at this place, we experienced earthquake shocks, each lasting from 5 to 20 seconds. We named it Earthquake Camp. A few hundred yards back of us, there is a small group of mud springs, in which the mud was of a pure white color. About 2 miles northeast of the lake, we discovered a small lake, which was named Turbid Lake from the muddiness of its water. It tasted of alum, and there seemed to be numerous springs throughout it, as there was a bubbling all over its surface. On its eastern shore, there was a group of hot springs, mud springs, and vents. The largest spring was situated in the midst of a small stream flowing into the lake and had a temperature of 186 degrees Fahrenheit. On the side of a small hill, at whose base the principal mud springs were situated, there was an abundant deposit of sulfur and alum. In some places the mud had become quite compact, and upon being broken revealed the presence of sulfur running through it in veins. Almost all these springs gave off sulfurated hydrogen gas. The temperatures varied from 176 degrees Fahrenheit to 1,920 degrees Fahrenheit. A short distance north of this group, there were some large mud springs, one of which was white and another black. The latter had a large quantity of sulfur in its composition. On the northern shore of the lake, there are 4 or 5 cold springs containing chloride of sodium. This place is used by the deer and elk as a lick. Our horses recognized the presence of salt at once and licked the ground with avidity. Nearly all the springs near the Yellowstone Lake seem to have passed their most energetic stage and are now on the decline. On the 23rd of August, we left Yellowstone Lake and, taking a northeasterly direction, started on our way toward the east fork of the Yellowstone River. The first part of our route was along Pelican Creek, one of the tributaries of the lake, which we followed to its source, crossing the divide between it and the branches of the East Fork toward evening, when we camped at the shore of a beautiful little lake in the woods. The valley of Pelican Creek is quite wide, and the stream flows through it in a serpentine manner, its waters covered with wild ducks and geese. There were a number of springs scattered along its banks, the majority of them cold. One, however, had a temperature of 66 degrees Fahrenheit. There were a few geyser cones, although as geysers they are probably now extinct. We reached the southern branch of the East Fork the following evening, after a day of hard travel through the dense pine forests and up and down steep mountains, and camped a few miles above the junction of the north and south branches in a wide open valley. In the bed of the stream, I obtained good specimens of agate, quartz, and chalcedony. Some were in the form of geodes and contained opal in the center. I also obtained black flint, green jasper, and excellent pieces of silicified wood, some of which were of a jet black color, having veins of blue chalcedony running through it. About 3 miles from our camp, on the north branch of the East Fork, was a large mound of hot spring formation, consisting chiefly of calcareous material resembling very much the formation at Gardner's River. It is conical, about 20 feet high, and 25 feet in diameter at its base. It is situated on one end of a sort of platform of the same material, which is 75 feet long and rises 15 feet above the surrounding level. It is probably an extinct geyser, although now there is no water in it, nor is there any hot spring near. There is, however, a cold spring near it, in which the water had an acid reaction, tasting strongly of iron alum, of which there was quite an abundant deposit about it. It is situated on the bank of a small creek and gives off sulfurated hydrogen. We reached the junction of the two forks of the Yellowstone on the 25th of August, having made the circuit of Yellowstone Lake, including the geysers also. Near the junction, there is a large extent of ground strewn with huge granitic boulders. Farther up the East Fork of the Yellowstone than we went, there is said to be gold, although at the present time it is unsafe to mine there on account of the Indians. I was given several specimens of galena and pyrites, said to be from that locality, from surface diggings. We crossed the Yellowstone on the first and only bridge over its water, which was built here by one of the trappers in anticipation of a rush to the gold diggings of Clark's Fork. From the junction we followed our old trail, past the White Hot Springs, the Devil's Slide, and the Lower Canyon, to Bottler's Ranch, getting into the permanent camp on the 27th of August. On the opposite side of the Yellowstone from our camp, there is a high volcanic peak, one of a long chain. It bears the name of Emigrant Peak and rises 10,629 feet above the level of the river. Its summit is composed of a very dark, compact basalt containing a few small crystals of mica. Lower down it passes into a lighter variety. In Emigrant Gulch, which is at its base, there are granites and chloritic rocks. Specimens of pumice stone were found near the head of the gulch. There is some little placer mining for gold carried on in the gulch, though as yet not in a systematic manner. We left Bottler's on the 29th of August, arriving at Fort Ellis the following day. On the way, I obtained a specimen of a rhyolitic rock having a very compact, violet-colored matrix resembling the matrix of the fellstones. It was enamel-like and contained crystals of feldspar and mica. On the 5th of September, we left Fort Ellis, starting on our homeward trip. Fording the Gallatin and Madison rivers, we passed the junction of the three forks of the Missouri and camped near the Jefferson River. The valley is quite wide and well cultivated. The only rocks observed were limestone, which continued to the Jefferson. The river cuts its way through them, forming a deep canyon, obliging us to cross the hills east of the stream. Here we encountered gneissic and granitic rocks, upon which rested beds of reddish quartzites. On the 8th, we again struck the Jefferson, and followed it until we reached its commencement in the union of the Big Hole and Beaverhead rivers. The mountains on both sides of the Jefferson are granitic and contain auriferous lodes. On the side opposite that on which we were, there were a number, two of which are named the Highland and the Clipper. One has a depth of 300 feet and has been worked steadily for the last 3 years. At the base of the mountain there are 3 or 4 quartz mills. The formation we passed over was drift, containing quartz and granite boulders. The Beaverhead coming in from the left, we followed it to its sources. On the 10th, we camped at Beaverhead Rock. This is a huge mass of limestone through which the river has cut its way, leaving the rock on the left bank standing with an almost perpendicular wall facing the stream. From a distance, the resemblance to the head of a beaver is very striking, whence its name. Near here there is found a good quality of sandstone, which is employed in making grindstones. It is of a light gray color and of a good quality for that purpose. The next day we camped near Black-tailed Deer Creek, the rocks we passed having been similar to those of the day before, with the exception of red elvenites and fellstones, of the same kind that we met with on our way to Virginia City in June. They probably extend across the country. I rode up the valley for some distance and found the mountains to be limestones, alternating with white quartzites, for 6 or 7 miles. I also discovered a trap dike. Near the mouth of the valley there is an old hot spring formation, of which nothing now remains save the hard calcareous basins overgrown with low bushes and grass. The basins are on the side of a hill, and when the springs were active, must have resembled very closely the springs at Gardner's River. There is a small stream of cold water flowing over it. Reaching the Beaverhead River again, I proceeded up the stream through a rather picturesque canyon, at whose mouth were towering masses of a trachyte porphyry, which was vesicular, having a brown, vitreous matrix containing small, irregular cavities coated with blue chalcedony. This rock rests upon white sandstones of loose texture, which are probably of tertiary origin. Crossing the river, our road led us close by explorers of silicious clay slates, which were again succeeded by an igneous rock of a greenish-black color and specific gravity of 2.32, the cavities being filled with masses of chalcedony varying from the size of a pinhead to 2 inches in diameter. We also met with an old hot spring formation, probably connected with the one mentioned above as occurring in Black-tailed Deer Creek Valley. The deposit is calcareous, very hard, and the springs must be long extinct. The water, which is cold, flows over it, forming a small cascade. I obtained some good specimens of calcareous tufa. We also passed some beds of bright red sandstone conglomerates, or pudding stone, as the pebbles were small. We obtained specimens of a brecciated rock, which seems to be a friction breccia. The matrix is of a pink color and seems to be volcanic in its nature, while the fragments it encloses are silicious and of a greenish-white color. It probably occurs at the margin of the trachytic rocks found in the canyon. Our camp on the 11th of August was on Horse Plain Creek, in a valley covered in spots with quite an abundant deposit of alkali. Leaving here, the rocks first encountered were granitoid gneisses, succeeding which were alternate beds of limestones and quartzites, which continued, with the exception of a few igneous outbursts, until we reached the main divide of the Rocky Mountains, a distance of about 30 miles. On Sage Creek, in the foothills, there were beds of light brown clay slates, which were fossiliferous. We crossed the divide on the 14th of September over reddish quartzites highly metamorphosed, probably in part at least by contact with an outburst of igneous rock at the same place. We proceeded down Medicine Lodge Creek, camping on that stream in the evening. We passed by a bed of old hot spring deposit resembling a stratified limestone. It was about 60 feet in thickness. Near camp, there was an exposure of purplish-colored volcanic rock that I consider a trachyte, upon which rested a dark basaltic rock. Beneath these were white sandstones, very fine-grained and splitting into layers of 1 inch in thickness. They are probably Pliocene in their origin. Just before reaching the Snake River Valley, we ascended a broad plateau of basaltic rock like that bordering on Snake River. In crevices in the rock, we found obsidian. We crossed Snake River the second time, finding it about 20 feet lower than when we crossed it in June. We arrived at Fort Hall on the 19th and left on the 21st, proceeding up Lincoln Valley between hills of Jurassic limestone. We camped in the evening at Twin Springs, where there are the remains of old hot springs. Near us there were 2 extinct craters, and the whole valley was overflowed with lava. Leaving Fish Haven, we passed through Laketown, Randolph, and Woodruff, arriving at Evanston, Utah on the 28th of September. About a mile from the town, there is one of the largest coal beds in the West. It is from 22 feet to 32 feet in thickness. It crops out on the western side of a hill composed mainly of sandstones. It dips 100 north of east. There are 4 slopes being worked at present, 1 by the Wyoming Coal and Mining Company and 3 by the Rocky Mountain Coal and Iron Company. At the mine of the Wyoming Company, the main bed of coal is 22 feet thick, as shown in number 1 of the accompanying sections in Figure 64. Mr. Wardell is superintendent of the Wyoming Company, which works, in addition to this mine at Evanston, mines at Carbon, Rock Springs, and Almy. Figure 2 is a section at mine number 1 of the Rocky Mountain Coal and Iron Company. Numbers 2 and 3 are sections at mines numbers 2 and 3 of the same company. They are the same with the exception of the main body of coal, which in number 2 is 30 feet thick, and at number 3, 32 feet thick. In number 3, the clay above the main body of coal is 2 feet thick instead of 3, and that below, 5 instead of 8. Mine number 1 was commenced in June 1869, and the main shaft has been carried in a distance of 386 feet. It is 13 feet wide and slopes a little more than 1 foot in 4. At a distance of 150 feet from the entrance is the first level at right angles to the main shaft. It is 15 feet in width. On the north side, it has reached a distance of 330 feet from the main shaft, and on the south side, 450 feet. 150 feet below this is the second level, which on the north side has penetrated 330 feet, and on the south, 400 feet. From each level, chambers are worked through to the level above, parallel to the main shaft. They are 30 feet apart, and the entrance is 12 feet in width, which is rapidly widened to 18 feet. Mine number 2 was opened in August 1869 and has now reached a depth of 520 feet. It slopes about 1 foot in 4 and is worked on the same plan as number 1, with this exception, that the third level, instead of commencing at the main shaft, does so at the end of shafts which branch from the main one at an angle of 45 degrees. These shafts are, 1 on each side, 18 feet in width. The first level on both sides of the main shaft runs to the outcrop, a distance of 412 feet in each case. The second level, a distance of 150 feet from the first, runs to the outcrop 413 feet on the south side, and on the north has been carried 700 feet and will go 1,000 feet when it reaches the line between it and mine number 3. The third level penetrates 85 feet on each side. Mine number 3 was opened in April 1871 and has reached a depth of 190 feet. The first level only has been commenced, being 50 feet each side. It will be worked on the same plan as numbers 1 and 2. Each mine has 2 engines for hoisting the coal. There are 250 men employed, a large number being Chinamen who live in houses erected by the company near the mine. There is also quite a large store at the mine. The company supplies the Central Pacific Railroad and its branches in California and the Pacific steamship lines with coal. About 350 tons per day are mined, and the company expect to increase this. The officers are as follows: D. Colton of San Francisco, President; Fox Diefendorf of Corinne, Vice President; H. K. White of San Francisco, Secretary; C. T. Duell, resident at the mines, Superintendent; and G. A. Henry of San Francisco, General Agent. The coal is a lignite of a very black color and having a high luster. It breaks into parallelopipeds. It contains from 71 to 73% of carbon. The value of this bed of coal can scarcely be estimated, especially as it is situated in a country where timber is so scarce, and even the small amount that does exist is so liable to be destroyed by fires in the fall of the year, as we observed on our way up Bear River Valley. The iron ore that lies beneath the coal is of a light brownish-gray color, being argillaceous. It contains 35% of oxide of iron, 30% of lime, and 20% of silica. We left Evanston on the 1st of October and arrived at Fort Bridger the following day, where the expedition disbanded.